Cool. So, good morning, folks. That's good. That's good. After 2 keynotes and having a party last night, that's definitely good. So, we're going to talk about managing requirements for Python projects. Mostly, it says like for more like 1K contributors, software, whatever, blah blah blah. That's mostly because I work on OpenStack and that's what we have there. But you don't necessarily need to have such a big project to actually implement any of these things that I'm going to talk about here, which are not necessarily the best ones, just the ones that actually work for us. And if you have ideas, please just come and talk to me. I've heard that having cats in presentations is good, so here's one for you. And here's another one just to break the ice and everything. And that's it about cats because I actually hate them very much. And I prefer dogs, and I would like all dogs eating all cats. Anyway, that is me. Feel free to interrupt me at any time. If you have questions, if you have doubts, if you have ideas, whatever, if you think I'm going too fast or too slow, just interrupt me, talk to me. I would rather be interrupted in the specific slide and the context I'm talking about, rather than having a whole bunch of other questions at the end and not knowing what you're actually talking about or referring to. Thank you all for being here. I work at Red Hat. I still work at Red Hat. I'm there. I work on OpenStack most of the time, hence the shirt and the stuff I'm going to talk about here. This is my Twitter handler. That's Flapper87, Flavio@redhat.com. Please do follow me. Someone has to feed my ego, and that's you. So help out with that. If you like the talk, tell me. If you don't like it, just don't tell me. Jokes apart, I'm very open to suggestions and feedback, so just please shout out and help me out here. Some disclaimers, and I promise I'll get to the point and I'll start talking. I say bad words. It's not about you, it's just me. I rant a lot, although I hope I'm not going to rant this time. Except that pip actually sucks a lot, and sep.tools is actually awful, and I hate all the Python packaging system. But that's another story. I normally speak very fast, and I was told that we're like 15 minutes late, so I'm going to speak faster. If I'm going too fast, just let me know, and I'll try to slow down. And this is the first time I give this talk here. So again, feedback. If you think some things should be explained a little bit better, just let me know. I would love to improve it a little bit more and be able to express the ideas and stuff we've done a bit better. So we're going to start talking about the problem we have, or the problem we actually had in OpenStack, and then we'll go through why we have that problem in OpenStack. If you don't know what OpenStack is, don't freak out. I'm going to explain it in a bit, so bear with me here. I'm going to walk you through the OpenStack kind of like project architecture and not exactly how it works, but how it is structured code-wise. So after explaining you how OpenStack is structured, I'm going to talk to you about the solution we've implemented. So bear with me a little bit. If you have some doubts, some questions, feel free to interrupt me, but bear in mind that I'm going to probably just walk through those as well. So the problem, we want to know what we depend on. So we have this huge project called OpenStack that has many smaller projects in it, and they all are supposed to be co-installable under the same virtual environment. So having separate virtual environments for each one of them is not a solution. So we need them to all run under the same environment and using all the same like side packages there where Python imports everything from. We need to maintain all the requirements in those projects synced. So we need to all of those projects to have the same requirements list, the requirements file, just to make sure they are consistent. And we have a better story to tell to packagers from distributions like Ubuntu or Fedora, because they have to package that stuff. And they want to have, like, they don't want to have different packages depending on different things, because they actually have very strict rules in what they package and what versions they put in there. So we really definitely want to know what we depend on. And so, welcome. Oh, by the way, Flapper87 is also my username on SpeakerDeck. These slides are up there already if you want to follow on with your laptop or you want to use them. I've uploaded them already because I'm on top of my shit today. So that's it. Going on. So what do we depend on? We want to know three things mainly of the dependencies we have in OpenStack. We want to know what the license of those dependencies are, because OpenStack is an Apache licensed software, and we want to make sure that the stuff we ask you to install, we can actually ship it instead of putting like shit in there that you are not able to use because of some weird license. So I'm not a lawyer, but I'm definitely, I know how to read and I know how to tell when something is open, like BSD or something, when something it has like some, it forbids you to do some stuff with your software. So we want you to be able to distribute OpenStack. We want like Red Hat to be able to distribute OpenStack. We want Canonical to be able to distribute OpenStack. So we gotta be very careful with the stuff we put in there and the third-party libraries licenses that we have. We want to favor pure Python libraries over like built ones, like binaries, because building those dependencies is actually hard, and it normally breaks the gate and the CI system, and it also means that you have to have a specific version in your environment, which means that Fedora or Red Hat or Ubuntu have to have those specific versions of the library installed and compiled and whatever. And we want to do Python. We don't want to deal with some weird like build errors or other stuff that can come up of it. So we want to favor pure Python library. So we want to have a way to actually understand when you are adding a new dependency whether there's a better one for you that is pure Python. And of course we want the dependency to be Python 2.7 compatible, but also Python 3.4 or 3.5. We're actually moving to 3.5 now. So it is a huge deal for us because we are putting a lot of effort on migrating from Python 2 to Python 3 and having OpenStack being compatible with both of them. It's a huge effort. It's required more than a year and a half to do that, and we're not there yet. So we definitely don't want new dependencies that are not compatible with Python 3 because we want to get there at some point. We want to keep all the requirements synced, which means if we have several projects, we want all those projects to have the same requirements file because of the reasons I explained before. And we want packages to have a better story and not have to depend on several different versions because they're not going to do that. So Fedora is not going to depend on several different versions of the Python request library. They just have one, which is the one they ship, and we want to make sure all projects that depend on the request are able to use the same version. Mostly because of that and because they have to be, as I mentioned before, co-installable. We want the compute requirements, we want the storage requirements, we want the network requirements, all those projects to be able to be installed by using pip and be able to coexist under the same environment. So whenever I run Neutron, which is a network service, or I run Nova, which is a compute service, I want those two services to just run and not run into some dependencies conflict. So this is a problem, right? This is all the stuff we definitely want to fix, but it doesn't stop there actually, because it is not only the dependencies, the direct dependencies we have. So if you have a client library, or if you have like the compute service, and this compute service depends on a very well-known request library, turns out the request also depends on some other libraries, right? So we want to have full control not only of the dependencies, the direct dependencies we have in OpenStack, but also the transitive dependencies we have. So if the library we're using depends on some other library, we want to also have some control over that, because that library can actually break my system. If something happens to that library and some other project depends on that library as well, and they have conflicting versions, that's going to break OpenStack. And that has happened several times in our CI system. So it is a chain that goes as deep down the dependencies chain as possible and as we have to. So we're gonna record and control all the transitive dependencies we have, because we've gotta be able to determine or to tell you when something breaks, what broke, and exactly where and why, so that we can fix the gate, fix the CI system, and tell you know what, that specific version is broken. You should probably just upgrade it, and all the services are just gonna work. And this is all essential not only for for you that are using OpenStack, but also all the CI systems that we run on top of. So each project has its own CI system. There are integration tests, there are functional tests. So there are CI jobs that all run a specific task that require all the projects to be installed, and they run all the functional tests on top of the API. So it is essential for us for this to be solid and to not break. So again, that's the problem. There are three main things. What do we depend on? Keeping all the requirements synced, and being able to co-install all the services that we have in OpenStack. So why do we have this problem now? Who of you know what OpenStack is or have heard of it? So, a couple of hands. I'm going to do what I normally do when people raise hands. I'm just going to ignore you and go ahead and explain everything, because that's more fun. At least I know you're all awake, or kind of. So what's OpenStack? That's the OpenStack mission. I'm not going to read it, although that is true. We're kind of changing it to be able to put users in there and some other stuff that we actually care about, like interoperability. But that's the OpenStack mission. The TLDR is we want to build open source clouds. We want you to be able to create your own cloud by just installing OpenStack and have virtual machines and storage and networks and all those fancy things that you see on AWS, which are not actually super rocket science. You can actually have it in your home with your commodity hardware and everything. So you can build your cloud for your own purposes and test it at home, but you can actually build a company on top of it, like Rackspace, for instance. I should start charging for mentioning Rackspace. I keep doing yeah, or at least sponsor my trips. Anyway, so one thing that has happened in OpenStack ever since we started, ever since the project was created, is that the project was created with just the compute side of it, obviously, and some services that did storage, like S3. And of course, there was a need for having more stuff. We wanted to have networking, we wanted to have bulk devices, images, and we also wanted to have DNS as a service, firewall as a service, a whole bunch of things that you actually need to build a cloud. And something natural obviously happened. We just started adding more stuff. We added the authentication service, and then we added the database as a service thing. And then we added another project which is called Neutron, which does networking, and then messages as a service, because SQS exists, and there's SNS as well, and it's very important to have messages in your cloud. And then we also had images, because you need to boot your virtual machines from something, and that's the images you actually upload to your cloud. So we provide you a service. We provide you with a service where you can upload all your images and boot instances from. And then each one of them had their own requirements file. And it turns out that 70% of the time the gate was broken. When I say gate, I mean our CI system. Is that fucking Jenkins that -1s my patches every time I put something up there because I'm dumb and I made some mistake. And there's this CI system that runs on top of every project, and it was broken every time because most of the projects had conflicting dependencies. And for instance, Keystone Client upgraded the dependency on request, but Glance Client didn't, and that was an issue because obviously the Glance Client required the Keystone Client required a major version of request than Glance Client. So Python is not happy with that because it does not differentiate with versions when it comes to install packages, which is really dumb, but that's Python. And what we did is, so since we had all these different requirements files, something we are not all very happy with this solution, but it felt kind of natural to just say, hey, we have many projects, and our problem is that all these projects have different requirements file, so the solution is to just create another project, obviously. And, oh god, that was a joke, but the solution is to create a centralized requirements management kind of project where we just upgrade the requirements there, and then we sync them to all the other services. So you can think about this project. The project is called Requirements because we lack of imagination for names. And So the project is called Requirements, and it is under the OpenStack organization on GitHub. So you can actually go there and see what's in there. And it's very simple. It has more scripts than actual requirements. And, sorry. And it has very few requirements files. The first one is the global requirements one. The global requirements one is a file that contains all the requirements for all the OpenStack projects, including transitive dependencies, third-party libraries, internal OpenStack libraries, everything. Everything is in there. It keeps track of the versions that projects depend on. And then we have the upper constraints one, which is the one that contains the last known working version that OpenStack was run with for a specific library. What I mean is, for Python requests, for instance, which is a library that we use quite a bit in the libraries, in the OpenStack libraries, every time the gate runs and the requirements gate runs, it will keep track of the installed request version, and it will just update the upper constraint and say like, hey, on this run we use this specific version, which is the I'm gonna make this up like 1.1.3. And it'll say, this is the last known version of the request that we run the gate with, and we're sure OpenStack works with this one because nothing broke, right? Or at least we're sure enough, because it is Python and something can happen. So we created this project. It's called Requirements again. It is a centralized project that keeps track of everything. And when I mean everything, I actually mean everything. It keeps track of the main requirements. It keeps track of the test requirements. So whenever you have a project, a Python project, it's pretty common to have two files in there for requirements. The first one is requirements.txt, which is the one that has all the project requirements. So those are runtime requirements. Those are runtime dependencies. When you start Python, when you're using your libraries or whatever, you need those to be installed. And then there's the test-requirements.txt, which is the file that contains just test requirements, which means you need those requirements just when you're running tests, just when you're testing your software, when you're running nose test or tux or whatever you use, you need those libraries to be installed. So we keep track of those, but we also keep track of the extra dependencies. So there's this thing. How many of you are familiar with the extra dependencies? It's kind of new in setup tools. You are. But you're kind of like Python core. You don't kind of. So no one. So the extra dependencies section is that. So think of this library, imaginary library. We're not gonna put a name on it because we just agree that we're not good with names. So think of this imaginary library that has different plugins. Right? And depending on your choice, you might want to use one plugin or the other one, right? But it turns out that these plugins have not the same dependencies. Like plugin A will depend on library X, plugin B will depend on library Y, and so on. As a user, I want to be able to choose what plugin I want to use, and if I choose that plugin, I want to just install the dependencies for that specific plugin, right? So if I want to use the plugin A, I would just want to install the library X because I don't care about plugin B, so I don't care about library Y. So I just want to keep my installed libraries and dependencies to the minimum possible, and that's what extra is for. I can tell with the extra section, and I really recommend you to just go look this up in the setup tools documentation, because it is actually pretty cool that you can do this now. And just go look it up. And it basically tells pip, there's a way to tell pips, hey, I want to use this specific plugin, so install the dependencies that plugin actually requires and not the rest of the dependencies. So you don't have to just grow the dependencies of your library. You can keep it to the minimum and then have optional dependencies, basically, that will be installed based on the user's choice. We keep track of those as well, because those can actually break our software. We keep track of the, as I mentioned before, direct and transitive dependencies. We keep track of the internal and third-party dependencies. So we don't only keep track of the internal OpenStack projects that we depend on, because we have like many libraries we've created in OpenStack. So we don't just keep track of those, we also keep track of all the libraries that we depend on that are third-party libraries and outside of the OpenStack realm. So I hope it is clear that we keep track of everything we use, and we try to be very strong about it. We don't want anything to be left out, because every library transitive of internal, it can actually break our software, and it has broken our software before. And to do that and be more strong about it, we don't allow to use -e in requirements files, because that basically means that you can install stuff from a Git repository or a random HTTP URL, and that's something that we cannot control. That's something that you can, like, you could put anything in there, and we don't have a track of it, right? If you put a Git URL and you say install the latest commit in this specific branch, I mean that can actually break our software, and that has broken our software before. So we don't allow external sources. We just want stuff that is on Pype. And again, no external sources. We don't. I'm just like reiterating and making my point even clearer. We don't want external sources. We just want stuff that is on Pype. We want stuff that we can, like, not necessarily control, because we don't control Pype, but we actually notice it comes from a trusted source. Although shit happens, like this is being recorded, I'm not going to say that. But anyway, it turns out that people think that they can delete released versions from Pype and no one is going to notice. And it has happened several times that we depend on a specific version, and it turns out the outcode is not happy with that version, and it goes to Pype and just deletes it, and they think that nothing's going to happen, and then they just break OpenStack completely. And that's a waste of time and engineering hours. Anyway, another rant. I said I was hoping not to rant today, but that's what I'm doing. So CI jobs forbidding untracked requirements. What that means is that so we have several projects, like I've mentioned several times already. We have compute, images, whatever. Each one of these projects have a requirements file, and we want to prevent people just to, like, adding stuff in their requirements file without adding them first on the global requirements repository. So each project has a job that checks that the requirements file they have is actually compatible and synced with the global requirements one. And if it is not, the project is asked to update the requirements file and make sure that it is using the same versions that are in the global requirements file. Just depend on the minimum working version. What this means is as a good practice, actually, this is not just something that we kind of invented and came up with. This is actually a very good practice to follow. Depend on the minimum working version of that specific library. So if you depend on request and you know that your software and your specific API works with 1.1.1, that has to be your minimum version. You don't necessarily need to cap it. And by what I mean with cap it is that you don't necessarily need to set a minimum and a major version that you depend on. It's actually recommended not to have a major version and not block your software there, because if you block your software, you're basically saying, I know this works, and I'm gonna just keep using this very tight and specific range of versions. And whenever something comes up and there are new releases and deprecations, warnings, and whatever, I'm not gonna realize that's happening, and there will be a time when I'll probably want to upgrade and use something new, and that will require more job for me, and that might basically just break my software. So it is good to have a minimum version because you know your software works with that one, but do not limit the upper side of that range. Well, I'm good at anticipating myself. So no dependencies caps again. Try to just keep it open at the end of the range, and just have a minimum version and install the latest one. We use requirements constraints. Who's familiar with constraints here? No one. Cool. The setup tools constraints. There's a new thing, that -c in pip, that you can actually use. So the Python constraints. Let's see if I can explain it actually. So it's another file. It follows pretty much the requirements style. You can just put the list of libraries there, library names and versions, and it keeps track of we use it to keep track of the working versions. Like I mentioned before, whenever we run the CI on the requirements project, we keep track of all the last known working versions that we run all the CI on top of, and that's all put in the constraints file. And every time we run the CI for each project, like Nova, Glance, or Cinder, whatever, we use the constraints file, and we just run that. And the reason we do that is because if there are new releases, they can actually break those gates, right? So we want to be able to just say, we are going to run the CI system with the versions we know that work, and that's basically what our scripts do right now. And then we're going to just keep them updated and try to have a periodic CI job that will run the requirements gate, and it will test everything and keep the upper constraints file updated. So I realized I didn't actually explain what the constraints file is. So it's a new thing, and it basically allows you to keep track of these versions. It's part of the pip command. You can use the -c argument and pass a constraint file, and I gotta run even faster. So whenever you're updating your dependencies, what we do normally, like in this requirements file, so we use reviews, code reviews everywhere in OpenStack, and we even use code reviews for updating the dependencies in the requirements project. So whenever we are updating the requirements project, reviewers of that project normally ask themselves these questions. I'm not part of that team. I'm just pretty happy that we have a team behind it and pretty smart folks behind it that are trying to keep our gate safe. So first, ask yourself if the dependency you're adding to your project has an acceptable license. If it is not acceptable, obviously don't use it, because lawyers. And ask yourself if it is Python 3 compatible. If it is not important for you, it should be important. But yeah, ask yourself if it is Python 3 compatible. And if it is not, try to find another solution that is actually Python 3 compatible. Ask yourself if it is actively maintained. This is super important. We've had from the past mostly depended on things that were abandoned at some point, and that required a lot of changes in OpenStack. And depending on how big your project is, it can be like hell of a burden to care on. But anyway, ask yourself if it is maintained and if the community behind it is strong enough that you can actually depend on it. Ask yourself if it is packaged already. This is not really a strong requirement. This is mostly if you are adding a new requirement in OpenStack and we realize that it is not packaged for distros, we'll try to find something that is actually packaged that is as good as this one. If we don't find anything, we'll just accept it and include it in the OpenStack requirements. And the reason is because we want to make the packager's life easier. We don't support any specific distro out there, but we do work with packagers and try to make their lives simpler because they are actually the ones that are shipping OpenStack basically. And obviously ask yourself if there's something similar out there that it could be better than the one that you're depending on. Or you can just ignore me and do it your way. But either way, if you decide to do something similar to this or just ignore me, these are some tips and tricks or kind of like summaries from the talk. Use the minimum version possible that you know that works with your software. Avoid dependencies that don't use senver. The reason is that senversion is awesome and it explains pretty much what the library is doing if you have a patch or minor or major release. So try to depend on stuff that is actually supporting senver. Capping is not always good, so if you can avoid it, avoid it. Favorite things that are on-pipey. I'm very strong about this. Even with our own software, I always say if it is Python and it is not on-pipey, it is not Python, because I cannot just install it with pip, and I have to depend on some other third ways to actually install that dependency, and I hate that because we already have a very crappy packaging system that we're trying to improve, and we're working on improving, so you should help us by just putting your stuff in there instead of giving us more trouble by installing stuff from other places. Pretty much. And keep track of the transitive dependencies. They can break your software, they're gonna break your software. And I guess that's pretty much it. I don't think there's time for questions, but you can just ping me outside. I'll be right here. I'm sorry about that.